Today we're doing lesson 11.4, rotations. Our I can statements for today, I can identify rotations, I can rotate figures in the coordinate plane, and I can use more than one transformation to find images of figures. So a rotation means the figure turns around a fixed point. So on this coordinate plane, my center of rotation is 0, 0. That's what it's going to be for most of the problems we do today. So I can take this shape, click on it, and I can rotate it 90 degrees clockwise. Clockwise means the same direction that a clock goes. I could rotate it 180 degrees clockwise, or I could rotate it 270 degrees clockwise. I can also take my original shape and I can rotate it counterclockwise, which is this direction. 90 degrees counterclockwise, 180 degrees counterclockwise, and 90 degrees counterclockwise. I'm sorry, 270 degrees counterclockwise. So our key idea, rotation is a turn. It's the type of transformation in which a figure is rotated around a point called the center of rotation. And then the number of degrees a figure rotates, that's called the angle of rotation. So for this first one, it says you must rotate the puzzle piece 270 degrees clockwise around point P to fit into a puzzle. Which piece fits into the puzzle as shown? So you have to think about this figure, and then 200 degrees clockwise means that you're basically flipping it 3 turns. So it's going to be positioned like this way. If we imagine that this was our coordinate plane, probably should have done that with P in the center, so let me fix it. All right, so if this is our coordinate plane, P is our center, and then we're imagining it going 270 degrees clockwise. So that's going to be right there. So if you imagine that piece rotated, and you think about where those points would be. So let's think about this hole. If I rotate it 90 degrees clockwise, that hole now is on the top. When I rotate it 180 degrees, that hole becomes on the right side of the piece. And then when I rotate it another 90 degrees to get it to 270 degrees, that hole is now on the bottom. So that means that my new shape is going to be shape C. 270 degrees clockwise is also the same thing as 90 degrees counterclockwise. It would still put me in this. If I imagine it rotated, that hole becomes down at the bottom. All right, so take a look at these questions, pause the video, and try them. All right, let's see if these are right. So which piece is a 90-degree counterclockwise rotation about point P? So if we go back to this one and we imagine it 90 degrees, which means you're really only doing one turn. So 90 degrees clockwise means that I'm taking this shape and I'm rotating it one space, flipping it one space around. So instead of that hole being on the left side, now it's going to be at the top. That means for that one, that's going to be piece A is going to be 90 degrees clockwise. Now, I'm looking at this now and I'm realizing I misread it. This one says 90 degrees counterclockwise, and that's actually the same as what we did before, which was piece C was our answer for that one. So it's still going to be C, counterclockwise 90 degrees and clockwise 270 degrees. That's the same thing. And then for 2, is choice D a rotation of the original puzzle piece? And then if not, what kind of transformation does the image show? So if we go back to choice D and we take a look at it, is this a rotation? No, it's actually reflection. If you imagine this being a line of reflection that you flip the shade across, this is what you would get would be the picture for D. So is it a rotation? No, it's a reflection. All right, so in our next problem here, the vertices of a trapezoid are W, and they list the points there. I won't read them to you. Rotate the trapezoid 180 degrees about the origin. What are the coordinates of the image? Notice when they're telling us about the rotation, they tell us two things. One, how many degrees, and then they also say where the center of the rotation is. The origin, that means 0.00. Almost all of the ones we do on a coordinate plane are about the origin, although sometimes we will look at ones that have different points of rotation. 180 degrees is really the same counterclockwise or clockwise, so you don't really need to say which direction. Either way, it's going to be 180 degrees. It's going to be a full turn. Okay, so I'm going to start by plotting my points. W is at -4, 2. So -4, 2, here's point W. X is -3, 4. So -3, +4, here's X. Y is -1, 4. So that's Y. And then Z is -1, +2. All right, so we're going to go ahead and connect those, make them into our trapezoid. Now, if I was doing this physically on a piece of paper, a lot of times people like to physically rotate that paper 180 degrees and then imagine what those ordered pairs, where that would be. So if we flipped that whole thing around 180 degrees, our new shape is going to be in quadrant 4, which is this quadrant right here. This is quadrant 4. That's where it's going to be. So I'm going to erase that X I was just doing there to show you that that's quadrant 4. 180 degrees is going to give us that. When we do 180 degrees, really our order pairs flip-flop. So our negatives become positives, our positives become negatives. So instead of the point -1, +2, now I'm going to do +1 and -2, and that's going to be my copy of point Z. And then for our next one, originally it was -1, +4 for Y. Now it's going to be +1, -4 for our copy of Y. Then I have -4, 2 for W. So now that's going to become a +4, -2. And for X, it was at -3, 4. Now it's going to be a +3, -4. Oops, that's an X. That's not a Z. So copy of X. This one was Y. All right. When you connect it up, it should look exactly like our original shape, same size, same shape, just rotate it. Okay, and then it did say on this one to list the ordered pairs of our new image, so we're going to go ahead and do that. So I'm going to start with the copy of W. That looks like that's now at 4, -2. The copy of X is at 4, -4. The copy of Y is at 1, -4, and the copy of Z is at 1, -2. Okay, our next problem, let's take a look at it. So we have a triangle here. They give us the vertices, and it tells us to rotate the triangle 90 degrees counterclockwise around vertex L. So here they're telling us how many degrees, they're telling us what direction, and they're telling us the center of rotation. So this one does give us the point instead of the origin. And then it says what are the coordinates of the image. So I'm going to start with my original picture. So J is at 1, 2. I go over 1, up 2. I plot point J. Then I have K is at 4, 2. So over 4, up 2, here's K. And then L1, -3. So I go up, or I'm sorry, over 1, down to -3. Here's my point L. I'm going to connect my triangle. So when you do a rotation around a point, you have to think about how the images are related. So 90 degrees counterclockwise. Okay, so we're rotating 90 degrees counterclockwise, which means we're imagining it flipping this way. So I'm going to start with point J. Now, right now from L to J, it's up 1, 2, 3, 4, 5 points up. When I rotate it 90 degrees counterclockwise, it's still going to be 5 points away, except now instead of going up, it's going to the left. So 1, 2, 3, 4, 5. Here's my new copy of J. And then I look at how I go from J to K. So J and K, K is 1, 2, 3 units to the right from J. And now once I rotate it 90 degrees counterclockwise, instead of being 3 to the right, it's now going to be 3 up. So 1, 2, 3. Here is my new copy of K. Don't want to forget about those apostrophes. And then my new copy of L, that's the center of rotation. So it's going to be in the same place. I am going to label my copy of L, but it's in the same place that it was before. All right, so now I need to list my coordinates. It does ask me to do that. So my copy of J, it looks like that is at -4, -3. My copy of K is at -4, 0. And my copy of L is right where it was originally, which is at 1, -3. Okay, let's take a look at this next one. A triangle has vertices and they list them there. They ask us to do a few different things here. So the first thing they ask us to do is to rotate the triangle 90 degrees counterclockwise about the origin. So they're telling us how many degrees, they're telling us what direction, and they're telling us what's going to be that center point. Remember, origin means 0, 0. So I start by plotting my points for my triangle. So Q is 4, 5. Over 4, up 5. Here's my point for Q. Then I have 4, 0 for R. So 4, 0 would be right here. That's going to be R. And then S is at 1, 0. There's my S. All right, so I'm going to go ahead and connect. There's my triangle. Rotate the triangle 90 degrees counterclockwise. So that counterclockwise is this direction. I'm imagining that entire thing being flipped. So if I'm thinking about it in my mind and I'm flipping the whole thing, originally my point was 1, 0 for S. If I rotate that 90 degrees and I flip it one turn of my paper, instead of being over 1 and up 0, now it's going to be over 0 and up 1. It's actually going to be at this point right here, which is that 0, positive 1. That's going to be my copy of S. Then for R, it was originally at 4, 0. If I flip it 90 degrees counterclockwise, now I'll be at 0, 4. This is going to be my new point for R. And then for Q, originally it was at 4, 5. If I imagine that instead of going over 4 and up 5, now I'm going to be going over -5 and then up 4. So over to the -5, up positive 4. That's going to be my new point for Q. And then I'm going to connect my points. You can see my new image. There it is. So that is part A. Okay, so then I'm going to look at my next one. So B says rotate the triangle 180 degrees around vertex S. So I think A, I'm just going to like circle this in red here. That was my red triangle. Now I'll do it with green. So B is going to be my green triangle on here. Rotate it 180 degrees around vertex S. So vertex S is this one right here. It's going to stay the same. It's my Q and my R that are going to rotate. So R is 1, 2, 3 units to the right of S. If I flip it 180 degrees, it's going to be the exact opposite. So instead of 3 to the right, now it's going to be 3 to the left. 1, 2, 3 puts us right here at -2, 0. That's going to be my second copy of R. Then I'm going to do from R to Q, it looks like I go up 5 spaces. So now instead of going up 5 spaces, I'm going to go down 5 spaces. So starting at R, if I go down 5 spaces, that puts me at -2, -5. That is my second copy of Q. And my second copy of S is still at the original point, which is at 1, 0. So here's what my new triangle looks like when it's 180 degrees rotated about vertex S. And then C, are they congruent? Yes, they are. They are both reflections of the same, not reflections, sorry, rotations of the same figure. If you have two figures that are rotations, they're still going to be congruent. The size isn't changing, just the position on the coordinate plane. So both rotations of the same figure. All right, let's take a look at our next problem. The vertices of a rectangle are, and they list them, rotate the rectangle 90 degrees clockwise about the origin, and then reflect it in the y-axis. What are the coordinates of the image? So they're asking us to do two steps here. We're putting together two things that we've done so far. So I'm going to start with my original image here. I think I'll use black this time. So I have A, -3, -3. So I'm going to -3, -3. There's my original A. B is at 1, -3. So here's my original for B. C is 1, -5. So here is where C is. And then D is -3, -5. I'm going to go ahead and connect them. All right, so there's my original image. First thing it asks me to do is rotate the rectangle 90 degrees clockwise. So clockwise is turning it like a clock. That means we're going to go in this direction. That means my rectangle, instead of being in quadrants 3 and 4, is now going to be in quadrants 2 and 3. If it helps, you can physically rotate your paper and see where your new points would be, or you can kind of rotate it in your mind. If you flip your head a little bit to the side and imagine it being turned 90 degrees, then you can kind of visualize where those new points are. So starting with point A, it originally was at -3, -3. When I rotate it 90 degrees, now it's going to be at -3, +3. It's going to be right here. So there's my copy of A. Okay. And then for my copy of D, originally D is 2 units down. Now it's going to be 2 units to the left. So here's my copy of D. From A to B, originally that's 1, 2, 3, 4 units over to the right. Now it's going to be 4 units down. 1, 2, 3, 4. That's B. And then for C, it looks like that is 2 units down compared to B. Now it's going to be 2 units to the left. Okay, so that's where my first copy after my rotation, that's where what it looks like. Now my second thing they asked me to do, number one, I rotated at 90 degrees and we went clockwise. But now we need to reflect it in the y-axis. So my y-axis, that's the vertical one right here, that's my y-axis. So we're going to reflect it. So copy of A looks like on the y-axis is at 3, and it's 1, 2, 3 to the left. Now I'm going to go 3 to the right. Here's my double copy of A. So I'm going to go ahead and list it. It asks for the coordinates here. So I'm going to list them as I go. So my copy of A looks like is at 3, 3. Second copy of A is at 3, 3. And then D, it looks like it's 5 to the left. So now it's going to be 5 to the right. That ordered pair, and it doesn't really matter if your list is alphabetical or not, is at 5, 3. For C, actually we'll do B next. So it looks like B is 3 to the left. Now it's going to be 3 to the right. Second copy of B is at 3, -1. And then my second copy of C is right there, makes a connection. Second copy of C, looks like that point is 5 and -1. Okay, and then our last type of problem, they ask us to describe a sequence of transformations in which the blue figure is the image of the red figure. So they're telling us that the blue is the image. Blue is the image. That means that is the second shape. And that means the red figure is going to be our first shape, where we started. All right, so if you take a look at our red shape to our blue shape, you kind of have to imagine a couple of things. What are we looking at? How did it get from one place to another? So to me, there are a couple different ways that you can do it. But I think the first thing that I see is a rotation. Now it looks to me like a 180-degree rotation because it's going from the third quadrant to the first quadrant. So it looks like a 180-degree rotation to me. Now you have to be very specific about it. So 180 degrees, it doesn't really matter what clockwise, counterclockwise for 180 degrees. So 180 degrees, and then I'm going to rotation about the origin. You do need to say where it is. So if I did my 180-degree rotation, I'm just going to go ahead and sketch in what that looks like. So that actually 0, 0 would stay the same because it's going about the origin. So if I'm rotating 180 degrees, it looks like, so let's see, if I did 180 degrees, it would look like this. And then let's see, this would be 1, and this would be 1, 2, 3, 4. So let's see, 1, 2, 3, 4. It looks like that would look like this. So now that I'm looking at it, I don't think 180 degrees is the right amount of degrees, although it is a rotation. So I do need to go back and think about how many degrees I want it to be. So what I was visualizing would be having the shape look like this. So a rotation, it is about the origin, but actually it's not going 180 degrees. So if I did it a 90-degree rotation, let's see, actually that's what I'm going to do is a 90-degree rotation would make it look like this right here. So 90 degrees, that's going to have it look like that. So yes, that's what I want. So I'm going to do 90 degrees, and then that's going to be, it's going this direction. That's counterclockwise. So I'm going to label it in here. Okay, so now that I've rotated, I see a translation as my next step. Okay, so for my translation, it looks like I'm going up 1, 2, 3, 4. So 4 units up. All right, and we are going to stop right